Hi and welcome. Today we're together with Wouter Denayer, Chief Technology Officer at IBM. Wouter, you're kind of authority in Belgium and I think outside the borders of Belgium as well on artificial intelligence. Can you tell me a bit more on what you're doing at IBM and what keeps you busy most of the days?
Yeah, Yves, thank you, and thanks for having me. Of course, if you call me an authority already, I think if you call yourself an authority, then something's wrong. And it's almost impossible, by the way, to follow everything that's going on in AI. The progress is actually amazing. But you are right. I do love to follow everything that's going on as much as possible, especially focusing, I would say, on what IBM Research is doing. We can come back to that later. And that's part of my role, right? So in my role as CTO for IBM Belgium, I communicate a lot with C-level people in our strategic clients, big clients, sometimes global clients that really want to know what's coming. You know, what is this AI thing? We're beyond that. People understand more or less. But they want to know what's coming, what's next, how can this have an influence on my business, how can I make use of this technology most of all, and how does it fit in my current approach. So that's kind of what I try to do, is to explain, to evangelize in a way, but with some deep technical understanding of how things work, right? I think that's what I try to do, is really understand and convey how things work and what they can do, and also what they cannot yet do. There is a lot of hype, as you know, going on, and I do my best to avoid all of that and to clarify, the reality of things, if you want.
Yeah, like you say, you're try to keep on top of it and see how is the best match. We've come a long way. Artificial intelligence, a big hype word. It's coming from the 60s. You said that the first AI that we saw was able to recognize 6 or 16 words. I don't recall anymore. And we all have these ideas that the computer will take over. So I think we had a big learning path last years. What we see evolving. You called it general AI in previous discussions. What do you see where we are on this turning point with AI? What did we achieve last years, and what are the bottlenecks?
Right. Yeah, that's true. Of course, the general AI is this big idea that computers basically will be able to think and reason like humans. And that's been the goal or the ambition level since the beginning of computers, because from the absolute beginning, people tried to use computers to mimic the human brain. Even Alan Turing, for example, created a chess game, first chess game that ever existed on a computer. Although the computers, the hardware were not there yet, so he had to do all of that in his mind. He's, of course, is the grandfather of computing. He invented basically the basic principle. And he had to, just as an anecdote, he had to play this game by hand. Calculating each move took him half an hour per move, but they did it. And so he proved basically that a chess program could be built. And chess, as you know, has been always considered as a kind of the realm of people. If you're a smart person, intellect is kind of epitomized by chess. And so people thought if we can copy chess, then we're there. Then we have intelligence or general intelligence. This also culminated much later, I would say, in the big IBM Deep Blue win against Kasparov, the greatest chess player of all time. We can probably say, but still, then it turned out that even that is not intelligence. That more is needed, and that does not generalize. That the software could play chess amazingly well, could win against the best human player ever, but could not generalize, could not think about anything else. It could not do anything outside of chess, right? And so that's the principle of general intelligence, that we can have an intellect, a computer intellect, that can do all the things that humans can do. So that get more broad, right? And so we are not there by a long shot. That's not to say that we did not make a lot of progress. We did. It's quite amazing. If you see what's happened, I would say in the last 8 years with the neural networks, there's been an explosion in capability. Especially, I would say, in visual recognition, for example, audio, speech recognition. We can all talk to our mobile phones now, and speech is pretty well recognized. And so people thought, wow, this is amazing, and it is. But then people extrapolate and they say, if we can do all this in such a short period of time, in 8 years, then surely very, very soon we will have a system that can think like a human. And of course, then the science fiction movies get into the picture, and people think, that the evil AI is coming. Well, I can reassure you, it's not coming. It's not coming because we are not there by a long shot. We actually don't know how to build such a system. And I'm not afraid. I don't think you should be afraid, Yves, because we are very, very far away from that. We are making progress, making the speech recognition better, making the image recognition better, but making hardly any progress towards general AI.
And what do you see? Well, these are kind of people are frightened from this, so they say we can't see what the program is doing, what is the expected result. So I think the fear comes from that. You explained a bit the explainability, and that's a part of that will help overcome or just adapt or accept these ways of working with hardware and software. Let's call it like that. What do you see could help in bringing that acceptance towards the people working with, let's call it an AI?
So indeed, we are making progress, and smallish AI systems are finding their way into the workplace. We are being helped and kind of helpers. But people are a bit, wary or a bit not afraid maybe, but they don't really understand. And to be able to really make full use of the AI systems in the workplace or outside of the workplace for that matter, we need to trust the system. And that is a keyword, right? Trust is a keyword. And we don't trust things that we don't understand. So first of all, some of the things I do is explaining where are we really, why you should not be afraid of the evil robots. What can we really do? So that's one part. And then the second part is, if we accept that, then we should still understand why a certain decision was made, right? So take, for example, a loan. If I go online to my bank, okay, on the website, I type all my information and I ask them, will you give me this loan? And the bank on their side, they want to assess the risk. And that's what they do. They want to make sure that you pay back your loan. And so if, for example, they say, well, dear client, we cannot give you this loan, then I want to understand why. It's plain and simple, because I don't just accept no. They cannot say, no, the machine said no. I need to understand. And the problem with AI systems today is that we use neural networks inspired by the brain that are essentially a black box. So they do their magic, they work pretty well, but we cannot look inside of them. We cannot understand what's going on in that black box. And so we get an input. This is my file. I make so much money. This is my age. I am married or not, or whatever. And then the output is, yes, you get a loan, or no, you cannot get the loan. And essentially, up to now, the case was we didn't understand what was going on. We knew the system was correct in 99.8% of the cases, which means it's wrong in 2 out of 1,000 cases, by the way. And we could not understand or see inside of the system. And that is problematic. Because if I don't understand why something is going on or decided, I cannot change anything about it. I cannot see if it is fair. Is that a correct decision, or is the system making a mistake in this case? Is there maybe some bias going on? Maybe some sexism? That is always possible. Maybe the system was not trained very well. It happens, and there have been very well-known cases published about this. So essentially, it comes down to understanding. If I don't understand the reasoning of the system, I will not trust the system. It's very simple. As a client, I'm disappointed because the bank cannot explain to me why the loan was denied, right? For the bank itself, it's a problem because now they have an upset or angry customer. And the regulator will also be not amused because the regulator must make sure that the bank is fair, that it's a fair business and that it is not, for example, biased, right? So for all these different cases, it's necessary to look inside, to explain, and that's where we then use the word explainability, the ability to explain, to look inside of the AI. And up to very shortly, it was really problematic. And now we are making progress. For example, within IBM research, we'll be able to look inside now of the neural networks, maybe translate this complex decision into more simple, understandable parameters, like make me understand, that maybe my income was not high enough, or maybe there was just not enough money on my account, or maybe I should have my salary, be dropped on the account of the bank and not of another bank. So once I understand, I can also act, right? I mean, the bank could give me advice.
So yeah, not only that you get the bylaws and the policies, whatever, and you have to make up your mind to understand it, but just in a conversational way that you understand why the decision was taken. What do you see can help in the future, in the next steps, or let's call it the next AI evolution? How that can be? What are the other aspects that could help in the adoption?
Yeah, so one of the things we see is that AI systems and neural network systems, they are based on statistics, and they make mistakes. It's a bit like the human brain, unfortunately. Yeah, it's very optimized. We are all proud of our brains, and we should be. But still we make mistakes a lot of the time, and so we want to make sure that these statistical systems, these neural networks, that they don't make the same mistakes as we, and we want to infuse common sense, some of the common sense rules of the world, right? And for example, in visual recognition, many mistakes are made that a human would never ever make. For example, there is this known example of a stop sign that is recognized by a self-driving car, and instead of the stop sign it sees, for example, a speed limit sign, because there has been some small manipulation. Some people put some stickers, some black stickers in the right place, they carefully choose this place, and so they fool the AI into recognizing a stop sign as a speed limit sign, which is totally different, I'm sure you agree, which is problematic, right? If I'm driving my self-driving car, this is a real problem. And at the same time, a human would never ever make that mistake. So we need to find ways to combat, to act against these attacks, and to make the systems again more robust. So that's one thing, getting more robust. Second thing is infusing common sense. And common sense is knowledge of the world, right? Knowing that certain things are impossible, that they cannot just be like that. And so common sense is a problem, because for a long time people thought that if we train a big neural network, a big AI system, then it will learn by itself the common sense. We feed it, for example, all the text that is available on the internet, and then it will learn also common sense. Now, it turns out that it doesn't. An example I sometimes use is the color of sheep. If I ask you, Yves, what is the color of a sheep? It is?
You say white, no?
White, yes. Well, if you look at the text evidence, and if you have asked the same question to an AI system, they will say black. And the reason, it's crazy, but then again, it's obvious, because in literature, in text, we don't say that sheep are white, because of course they are white, right? It's not something we have to say. So it's not present in text. And of course we know the expression, black sheep, it's a well-known expression. So that's what the AI is encountering. So tada, statistically speaking, for the AI, sheep are black. This does not make any sense, but clearly shows you, right, that there is something missing. That is something missing. And so we need to bring common sense into the system. It's not working out through statistics or through reading massive amounts of text. It's not working out through making the AI systems bigger and bigger and bigger and bigger. So we need something else. And we basically, and this is interesting, we are going back to solve that problem, going back to the beginning, right? So if I talked about Alan Turing and his chess software program. So to play chess, you need a number of rules. And what Alan Turing did, of course, they put the rules into the system. A human put the rules into the system. It's called Symbolic AI because it's working with symbols, in this case, chess pieces, and we tell the computer what are the rules, okay? This piece of chess can only move in this way, and the other piece can only move in that way, and we give it knowledge of the world. We also give it a big database of all the previous historical chess games, and we say, okay, you can reason with that. But we feed it a lot of information. That's how we worked in the past. Then after that, neural networks came, and we say, okay, all these rules, it's too much work, The rules change all the time. We cannot do it anymore. Let's learn everything from the ground up. That turns out also to have its challenges. And now we combine both of them. So we take all the best of the neural networks, statistical, probabilistical learning from the ground up, and we bring back the rule systems, the symbolic systems. And that is the next avenue, the next wave in AI now is basically bringing these two paths together in the best possible way to solve the common sense problem. By the way, it's also solving another problem that we have today is that, we read a lot of examples. If we want to recognize 1,000, cats and dogs and whatever animals, we need 1,000 examples of a cat and 1,000 pictures of a dog and so forth, right? And it's time consuming to gather all these examples, to feed them into the system. And in some cases, it's also not possible. So what we want is to have an AI that can learn with less examples. Because as a human, I also don't need 1,000 to see 1,000 dogs to recognize a dog, okay? I mean, a child can do this from 1 or 2 examples, right? So this is inspiring for us, like how can we build this system based on the symbolism of the past combined with the neuron approach, the neural network approach of today, to build also systems that can learn with less data. And this is very promising, and we're taking a lot of attention on that path now to move forward towards general AI, this holy grail again. So yeah, that's a new movement that's going on.
So that means, like if you say with less data, that means you're becoming better or creating the right context and the right connections between things. I'm just thinking on how my mind sometimes jumps from one thought to the other thought and connecting things. And you got these theories and you got frightened as well sometimes. And you have to step back and reflect on, hey, is this right what I got with the input and the associations what I'm making? So that kind of rule-based, but it will then become kind of combination between human common sense and the common sense that the machine is learning then.
I mean, there is a big history and a big body of work, I would say, that was built out in the last 50 years around symbolic AI. There are many problems that we can solve in the traditional symbolic way, and we can now use all of these things that we have learned and combine them with the neuron approach of AI. And for example, if we want to solve a puzzle, you know these sliding puzzles, like you have nine images and you have to slide them and to make a dinosaur, like for little kids 5 years old, right? This problem is very easily solved. It's a planning problem. You have to plan your moves. First I move this piece here and then I move that piece there, and it's a planning problem. It's easily solved if I give all the information to the AI system. Then I can use a classical planner. If I tell it, these are the pieces that you can move, these are the moves that you can make. You can only move up, down, left, right when there's a piece. You can only move up when there's an empty space above the position where you are. You can slide the piece upwards. So if I give the computer all that information, it's really an absurdly simple problem to solve. But if I don't give it any examples, okay, I just give it the puzzle which is not solved, and I tell it, this is the solution, but you figure it out, okay, just figure it out by yourself. And I just give you very few examples of showing just a slide move, but I don't tell you anything else, okay? That's an extremely hard problem to solve for a computer, because it does not have any context. It has to learn everything. It has to learn what the pieces are, what the possible actions are. It has to learn everything by itself. And so that was quite amazing. IBM Research proposed a solution to that, combining again symbolic AI with neuron AI, and combining the strengths of both, where with a very, very small number of examples, okay, the AI is able to solve that puzzle, which is really quite amazing, okay. But and the interesting thing is, once it's figured out what the symbols are, okay, then we can use a classical traditional planner algorithm. So we combine the best of both worlds, and we bring back into the system all that we've learned in the last 50 years. It's quite amazing. Yeah,
it makes me think of something I read about the evolution theory. If you say you just do natural selection, it would take so much longer, then we see how the evolution went. So the idea now is that we had, well, some shortcuts have been taken in there, and it relates to what you just told me on how we go about that symbolic AI, and then putting that together with the classical solution out of that.
Well, it's a good analogy, Yves. So we as humans, when we're born, right, we are not empty. Our brain is not empty. So we get all the structure in our brain from, millennia of since the beginning of time of evolution. So the brain has a certain structure. That's nature. That's what we're born with, and then we learn on top of that. And you're correct. We're bringing that back. We bring back again structure, and then we learn on top of that. So it's quite a smart approach.
Yeah, makes me think of my science lessons back in the day, where the teacher said all we do as humans is copy the nature and trying to put that in type of solutions. Makes me think, well, thinking back at the school days, a lot of knowledge is going to be needed in the future to support and build that next gen AI. How do you see that AI can help on bridging that shortage on skills for the AI? Is there a kind of solution to it? What do you see, Wouter?
What we're trying to do here is to use AI to build AI. So let me explain. So when you build an AI system today, it is quite a lot of work, and you need a very deep expertise. Okay, you need to find your data, you have to clean your data, you have to define the neural network models that you will be using, you have to tune them, you have to train them, you have to try again and again, and it's more kind of an art than a science, I would say. Okay, there's a lot of evolution in there, but it's very specialized work. And sometimes it can take months. If really top performance is very important in your use case, then it can take a large team quite a bit of time and resources, and compute resources, to actually come to a satisfying solution. Now, what if, and that's actually what we're doing, so it's not a what if, but it's reality today. What if we could have an AI that is actually helping you look for the optimal solution? So, for example, if I do visual recognition, there are certain neural network patterns. Think of them as connections in your brain, right? I can do it this way, I can do it the other way. There are like so many different ways I can do this. But what if I can have an AI that figures out, or that looks for the optimal way, that helps me look for that, and that helps me tune and tries 1,000 different ways and tells me probably this one is the best because I tried all of them. So it's kind of compressing the time that I need as a data scientist, okay, to figure out all these different options. Because otherwise what I will do is I will always use my favorite pet option, the one that I know, that I used in the past. But of course things evolve and there's now new ways and new tuning parameters and so forth. I cannot be aware of all of that. But what if you could have a tool that is aware of all of that and that can just test all of them, basically, and tune for you. And so we are at a point that these automated systems, so auto AI we call it, that they give results that are almost as good as the best human data scientists could possibly do. But instead of taking months to do that, they can do it, let's say, in an hour. Okay, I mean, that's just mind-boggling. That is changing the game, right? But I give them this powerful tool that really helps them accelerate and helps you accelerate as a business, the time to market with the best possible solution. That's auto AI. It's helping data scientists much more quickly figure out, what is the optimal way to solve this particular problem. And this is exploding now. And as IBM, we put it in our tooling, right? It's cloud-based tooling, and we make this very easy for you to do. By the way, in the same way that we embed and explainability. I think we are in the next step of artificial intelligence development, if you will, where in the past it was people playing around and working with a lot of libraries and figuring it out by themselves and building their own pipelines, and that's how development started in the past always. It's new, it's adventurous, and we bring everything together that we need. Of course, at some point you need to professionalize, and I think we are now at that point that this AI pipeline, like a DevOps for AI, if you will, it's being professionalized. And so that means that I control everything. I control my data. I control all the steps. I can have this auto AI play a role, right? I can embed explainability and all these things. I can check for bias in my data. And all of that I can do in a controlled way. Without jeopardizing the creativity again of the data scientists, because we don't want to do that. They know their domain, they know what they're doing, so we need to keep that freedom.
Yeah, there's the struggle that I picked up for data science projects. I see it in AI, and we saw it back in the days, even with development and typically in business intelligence. So history repeats itself. But do you see AI as well in the development for people? So let's say that it guides you in which kind of curriculum that you can take to develop your path, or if you say, this is this is the knowledge I want to achieve. Whereas now it's a predefined curriculum that exists.
Yeah.
Could that be helpful, where the AI looks outside on the internet, let's call it like that, and then defines, okay, this is some piece of information that is helpful for you. I see it already in the content curation platforms that I'm using these days. The AI is supporting me to select the content which is relevant to me based upon what I say, okay, these are the topics I do like to follow. So where do you see that evolution going?
Yeah, you see that as well. So in learning platforms, for example, so especially now, I would say in the special situation that we are all in with COVID-19, of course, people are maybe spending a little bit more time now on education, but where do you start, right? It's very hard. So there are these massive libraries of online trainings, and that's all good and well, and the level or the quality is very high, I would say. But what do I do first? I'm me. I have a certain skill set. I also have a certain expectation from my employer that skills that I should have. I also have an ambition, maybe a career ambition. I'm now here, but I want to go there. So how do I bring all of that together in a learning plan? A learning plan that's customized for me. So within IBM, for example, we've been using a platform we call Your Learning, which is basically trying to do that. It's curated content. So we know what the content is about, what the skill level of the content is, and so forth. But they also know about me. So they know who I am, they know my position in the company, they know what kind of projects I do, what my specialties are, they know what projects I work on, and they know my certification level and my profession. I'm an architect within IBM, but I could also be a salesperson or a project manager or a consultant. So they know all of this about me, and they can also say what my ambition is, and they know all of these things about the content. So it's clear that we have some matching problem here. And that's what we're starting to see. So when I come on the IBM My Learning platform, I am proposed certain learning curricula. Some are mandatory, things I have to do. Others are optional. Some are in helping me with my next certification level, for example, or keeping it up to date. So we see a lot of evolution there. And we also push, by the way, this platform outside. So we made it available to clients. In Belgium, for example, KBC is now using it or implementing the IBM Learning platform. And the nice thing is, it's not limited to your own content, okay? But we also bring in content from Coursera, content from Udemy, wherever it takes. And it's all controlled by your company. And they track what you do and how many hours that you spend on learning. I have a target, I have a learning target, how many hours I should spend, at least minimum. You can always overachieve, of course, if you want. And so it's really changing the aspect of learning. Whereas in the past, I would say the catalog was central. This is the big catalog, the library of learning. Now the person is central. I am central to the whole learning. But my employer has plans, right? And they want to make sure that on a whole they have sufficient number of people with certain skills and certain levels of skills, and they also want to track that because the marketplace is a tough place, so we have to be competitive. That's how it is.
Wouter, thanks very much for the insights in artificial intelligence, and that it will support us in a very positive and hopeful future. So thanks again. And see you soon.
Thanks, Yves. My pleasure.